Alright, so here is the explanation. I'll just jump right in. So for worksheet 4, I selected basic problem 5, which says given the first derivative of x, which is equal to 5, and given that f of 0 is equal to minus 2, we need to find f of x. So basically what we do is first we find f of x by taking the integral of the derivative. So the integral of 5 is just 5x plus c. And now to find the value of c, so we can have the final function, all we have to do is use f of 0 is equal to minus 2. So we replace x with 0 because x is equal to 0, and y with minus 2, or f of 0 with minus 2, and we'll get c is equal to minus 2. And here is our final function, 5x minus 2. To verify our answer, all we have to do is take the derivative of our answer, and if it matches with what we had initially, then we know our answer is correct. So we can see that the derivative of 5x minus 2 is equal to 5 because the constant becomes 0, and whatever is multiplied by 5, by x, just comes out directly. And we also can verify that our function is correct by putting f of 0 into it, and if we get the same answer as before, which is minus 2, then yeah, we know it's correct. Now here is worksheet 5. In worksheet 5, I selected the volume of revolution, problem 1 question, and what it asks is this: find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. So we have y equal to x squared, and we're starting at y equals 0 and ending at x equal 2, and we're doing that about the x-axis. So y equals 0 will become x equals 0, because if we plug y equals 0 into here, we'll have x squared is equal to 0, and we know that anything squared equaling 0 means that that thing is 0. So e is equal to 0 and b is equal to 2, and we apply the disk rule, basically because we're now trying to find the volume of a revolving curve. What that means is, say we have a curve, so it would be a bit like that, and you would rotate it 360 degrees to get a 3D shape, and we want to find the volume of that, so we use the disk method. And the disk method states that we should use this formula, which is basically multiplying pi by the definite integral of whichever function or curve we are trying to find the volume of revolution of, squared. So in here we had x squared, we will square that, we get x to the 4th power, and we know it is from 0 to 2, and pi is just a constant, it's part of the disk method. So now all we have to do is find this derivative, this integral, and multiply it by pi. So this integral is simple to find, at least this is the indefinite version. We know it is x to the 5 over 5 plus c, and now we can find the definite one by just plugging it into this. This is with b plugged in, and this is with a plugged in. The c's cancel out because in here it's plus and in here it's minus, and what remains is just this. If we put it into the calculator, we get 32 over 5, or 6.4, and we just multiply that by pi. Specifically this would be 20.1, but I did not include that. To verify, we just need to take the derivative of the indefinite integral that we came up with in step 5. If it matches the initial function that we were trying to integrate, which is x to the 4, then we know our integration was correct, and we're just relying on this, which is just basically using a calculator, so it's hard to make any errors in this. So we can see that x to the 5 over 5, when differentiated, will become 5x to the 4 over 5, which is just x to the 4, same as what we had initially. Now for worksheet 6. So our selected problem is integration by parts number 2, and what that problem asks for is integrating this function x cosine of x. So we know that integration by parts is the equivalent of the chain rule in the integration world, and to do it we need to first use the Elliott rule to find u and dv, and we can then use that to find du and v. So u, as we can see in here, is gonna be x, and dv is equal to cosine of x, using the Elliott rule, which says that logarithms comes first as being u, then inverse trigonometric, then algebraic, then trigonometric, and finally exponential equations. So since algebraic comes before trigonometric, we took x as u, and dv became cos x dx. And now we will find the derivative of u, which is just dx, because x becomes 1 when derived, and we will also find v by integrating dv. So if we integrate cosine of x, we just get sine of x. Now to step number 5, what we do is just apply the integration by part formula, which says that the integral of u dv is equal to uv minus the integral of v du. And number 6, we can see this in action. We just substituted everything, and in step 7 we did the second integral. So we did minus cosine of x, minus cosine of x is basically the integral of sine of x, and since there's another minus, they just cancel out and it becomes a plus. So our final function is x sine of x plus cosine of x plus c. This is our answer. To verify it, all we have to do is comment here and take the derivative of our final answer. If we end up with the initial answer, then we know it's correct. So what I did in here is break this formula into multiple parts, 3 parts, namely the first one is x sine x, which I just solved using the product rule of derivation, and we got 1 sine x plus x cosine x. Then there was the cosine of x, which just came out to be negative sine x using trigonometric derivatives. Then the derivative of c is just 0 because it is a constant, and putting all of this together using addition, we see that the final derivative is x cosine x, which matches our initial given function.